everyone. In previous lecture, we have seen what do you mean by electric potential and potential difference, what is its formula and its SI unit, and which is the instrument used to measure the potential difference. Now today we will see what do you mean by electric circuit and which are the conventional symbols used to represent the electrical component in an electric circuit or in a circuit diagram. So first of all, what do you mean by electric circuit? So electric circuit is nothing but a closed path formed by different electrical components along which the electric current flow. So that is called the electric circuit. Means in an electric circuit there are different electrical components which are connected with each other, so that the electric current flowing through that electric component, so that we get the required result. So that is called the electric circuit. Means in an electric circuit, the different components are connected with each other so that the electric current flow through it. And therefore, electric circuit is nothing but the closed path formed by electrical components along which an electric current flow. That is called as electric circuit. Now, the electric circuit consists of cell or battery, then plug key, and then different electrical components and the connecting wires. The electric circuit is represented by schematic diagram in which convenient symbols are used for different components. Now, which are the conventional symbols used to represent some commonly used electric components, and these symbols are. So these are the components and these are the symbols. So first component is electric cell. So electric cell, this is an electric cell we have seen. So this is an electric cell. So if this electric cell is connected in a circuit, then how it is represented in a circuit diagram? In this way. This is the symbol to connect the electric cell in a circuit. Then next is battery or combination of cells. If there is a single cell, then we can use such symbol. But if there are two cells, if there are two or more than two cells connected in the circuit, then it is shown in such symbol. Battery. Now, which is the battery? Now, this is the battery. So, this is an external source. So, such battery or the combination of cell is connected in an electric circuit, then it is represented by such symbol. Now next is plug key or switch. Now this is the instrument plug key. Now plug key is denoted by this symbol when the switch is open. Now this is the switch. Now when it is open means whenever the current does not flow through the circuit, or we can say when it is open, it means that the switch is off. So switch open means switch is off. It means that it is not now connected in the circuit. And when the plug key is open, it is represented by this symbol. Then next, plug key or switch is closed. Now plug key or switch is closed. Now this is closed. Now whenever we close the key, it means that it is in the circuit, it works in the circuit, and the current is flowing through the electric circuit. Now, therefore, plug key when it is closed, then it is denoted by such symbols. So if the switch is open means switch is off, then it is represented by this symbol. And if the plug key is closed means it is in the circuit and current flowing through the circuit, then it is represented by this symbol. Now next is wire join. Whenever we join the two connecting wires, then it is represented by this symbol. Now wire crossing without joining, where there are two wires cross each other, then in an electric circuit, then it is represented by this symbol. So this symbol represents that there are two wires crosses each other without joining. Now electric bulb. So whenever we use an electric bulb in the circuit, then that bulb is represented in an in the circuit diagram is represented by this symbol. So this is the symbol for electric circuit, electric bulb. Then a resistor of resistance R. Now resistor is a component which have a appreciated value or which have a common value or which have a a perfect value, for example 1 ohm, so that resistor having only 1 up to 1 ohm. So if it is 1.5 ohm, then that resistor having the value 1.5 ohm only. It cannot be more than 1.5, or it up to 1 point, it works up to 1.5 ohm. So resistor is a component which have a specific value, and this resistance is denoted by such symbol. Now next is the variable resistance or rheostat. Now what do you mean by variable resistance or rheostat? Variable resistance. Variable means in this case or in this component the resistance can vary. So this is the rheostat. This component is called as rheostat or a variable resistance. So in this component or in this instrument, the resistance can be varied. In this case, resistance having specific value. It is 1 ohm, 2 ohm, 3 ohm. That resistor having the specific value, that is resistance, which is denoted by this symbol. But rheostat is a component in which the value of the resistance can be varied. Suppose this is a resistance of 100 ohm, means it can vary the 100 ohm resistance. Means if we require 50 ohm, then we can move it and get the 50 ohm. If we require 90 ohm, then move and we get the 90 ohm. If we require 20 ohm, then we move it and we get the 20 ohm. So in this component, the value of the resistance can be varied. That is called rheostat. Means rheostat is a component which regulates current without changing its voltage source. So that is the advantage of the rheostat, that is it can regulate the current but without changing the voltage source. So such instrument called rheostat, and the symbol of the rheostat is like this. Then ammeter. Now previously we have seen ammeter. Ammeter is the instrument which is used to measure the electric current. Now this is an milliammeter, but that is called the ammeter, though it measures the current in milliampere, therefore it is called milliammeter. But though it is milliammeter or ammeter, if it is milliammeter, then we can measure it like this, milliammeter. Or if it is ammeter, then we can easily show it only A. So though it is ammeter, it measures ampere or milliampere, so according to it we can write here, but ammeter is represented by this symbol. Then voltmeter. Now voltmeter is the instrument which is used to measure the potential difference between the two ends of a conductor or between the two ends of a wire, and that is called voltmeter, and this is the voltmeter. This instrument is voltmeter. It measures, this instrument measures the voltage from 1 to 10 volt, and it is shown in this way. The symbol of voltmeter is like this. And the AC source, if we are directly using the AC source, then it is represented by this symbol. So these are the conventional symbols. These are the component, and these are the conventional symbols to represent the electrical component used in an electric circuit. So whenever we draw an electric circuit or draw a circuit diagram of any electric circuit, then we are not draw the light as it is or the battery. So can we draw battery like this in an electric circuit? No. So we can use only these symbols to represent these electrical components. This topic is Ohm's law. In 1827, the German physicist George Ohm proposed the relationship between the current flowing through a conductor and the potential difference across the two ends of a conductor. And this Ohm's law is nothing but, the Ohm's law states that potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current I flowing through it, provided that its temperature remains constant. So what is Ohm's law? Ohm's law is nothing but, now in an Ohm's law proposes the relationship between the current flowing through a conductor and the potential difference across the two ends of a conductor. So potential difference across the two ends of a conductor is V and the current flowing through that conductor is I. So he gives the relationship between V and I. And how he gives the relationship between V and I? That is the potential difference V across the two ends of a conductor. So whatever may be the potential difference between the two ends of a conductor in a metallic wire is directly proportional to the current flowing through that conductor, provided that its temperature remains constant. Means the temperature of the metallic wire remains constant. So why temperature of the metallic wire remains constant? That will be seen in next topic. But what is Ohm's law? Ohm's law is nothing but the potential difference across the two ends of a conductor is directly proportional to the current flowing through it. Or simply we can say that the potential difference is directly proportional to the current flowing through a conductor. So V is the potential difference across the two ends of a conductor and I is the current flowing through it, and both are directly proportional to each other. Now what do you mean by directly proportional to each other? Means if we increase the voltage, then current also goes on increases. Or if current increases, then voltage also goes on increases. So vice versa. So if voltage get increased, then current also get increased. So V is directly proportional to R. Now, if we have to remove this proportionality sign, we have to take a constant, and that constant is taken as R. R into R. That constant. So whenever we remove the proportionality sign, we have to take a constant, and therefore that constant is R. And therefore V by R is equal to R. So we get two formula, V by R is equal to R, or V is equal to IR. So V is equal to IR or V by R is equal to R is the mathematical statement or mathematical expression for the Ohm's law. So V is equal to IR or V by R is equal to R is the mathematical expression for Ohm's law. Now what is this R? R is nothing but the constant of a given metallic wire at given temperature, and that constant is called as resistance. So R is called as resistance, and this resistance is a constant for the given metallic wire at given temperature. Now what is that R? From this formula, R is V by I. Now what do you mean by resistance? As we have seen that the resistance is the constant of a given metallic wire. So what is that resistance? Resistance is nothing but the property of conductor which opposes or which resists the flow of current. So this is the property of a conductor, or this is the property of any metallic wire which resists or which opposes the flow of current, and that is called the resistance. And this resistance is nothing but the property of conductor to resist or oppose the flow of electric current. So resistance is the property of a conductor which resists or opposes the flow of electric current. This resistance is always denoted by capital R. Now what is this SI unit? SI unit. Now SI unit we can find out from the formula, that is V by R is equal to R, or we can say the formula for resistance is V by R. And from this formula we can derive its SI unit. So it's from SI unit, V means potential difference, and this potential difference is measured in volt, and current is measured in ampere. So potential difference is measured in volt and current is measured in ampere, and therefore volt per ampere. So volt per ampere called as Ohm. So again, Ohm is the name of the scientist on which the law is proposed, that is Ohm's law, and therefore volt per ampere, this SI unit called as ohm. So what is the SI unit? So SI unit is volt per ampere, and that is called ohm, and its symbol is represented by this Greek letter. So ohm is represented by this Greek letter, that is called ohm. Now from this SI we can also define 1 ohm. From this SI ohm we can define 1 ohm. So 1 ohm is 1 volt upon 1 ampere. So 1 ohm is equal to 1 volt upon 1 ampere. So how do we find 1 ohm? So from this formula 1 ohm is equal to 1 volt upon 1 ampere. We can easily define 1 ohm. There is no need to mug up the definition. So what is 1 volt? 1 volt is nothing but the potential difference across the two ends of a conductor, and 1 ampere is the current flowing through that conductor. So how we define it? When the potential difference across the two ends of a conductor is 1 volt and the current flowing through is 1 ampere, then the resistance of that conductor is said to be 1 ohm. Got it? So how we define 1 ohm? When the potential difference across the two ends of a conductor is 1 volt and the current flowing through a conductor is 1 ampere, then the resistance of that conductor is said to be 1 ohm. So in this way we can define 1 ohm, and this is nothing but the resistance. So what do you mean by Ohm's law? What is its mathematical expression? What do you mean by resistance, and what is its SI unit? So Ohm's law was first proposed by George Ohm in 1827, and which gives the relationship between the potential difference and the electric current. And what is that law? The law states that the potential difference across the two ends of a conductor in an electric circuit is directly proportional to the electric current flowing through it, provided that temperature is constant. Provided that temperature is constant, and therefore this is the mathematical expression, that is V is directly proportional to I. Whenever we remove the proportionality sign, we have to take a constant, and that constant is R, and therefore V by R is equal to R, or V is equal to RR is the mathematical expression for Ohm's law, where R is nothing but the constant of given metallic wire for given temperature. And how we define the resistance? So resistance is nothing but the property of the conductor which resists or opposes the flow of electric current. And resistance is always denoted by capital R, and its SI unit is volt per ampere, that is called ohm, which is denoted by this Greek letter. And therefore from the SI unit we can easily define 1 ohm. So 1 ohm means 1 volt upon 1 ampere, that is when the potential difference of 1 volt across the two ends of a conductor and the current flowing through a conductor is 1 ampere, then the resistance of a conductor is said to be 1 ohm. Now we will see how the circuit diagram is drawn for Ohm's law. The circuit diagram for Ohm's law. Now, whenever we draw the circuit diagram, this is the battery and this is the wire, or we can say this is a conductor. Between this X and Y point, they are attached the metallic wire. Then this is the electrical component through which we have to find how much current is flowing through it. Then across this wire, ammeter is always connected in series, and this is the key. And voltmeter is always connected in back. So in this way we will connect voltmeter and ammeter. So this is between X, Y, there is a metallic wire having some resistance. So this metallic wire having some resistance, and therefore as it has resistance we shown in this symbol. This is the symbol for resistance. And how the current flows? Current flows, the conditional direction for current from positive to negative, and this is the direction of the current. So in this way, the current flowing through the cell. So between X bar, we join the metallic wire through which we have to find how much current flowing through it, and that metallic wire has some specific resistance, therefore we denote as R. Then voltmeter is always connected parallel to the given component through which we have to measure the potential difference, because we have to measure the potential difference between the two ends of a conductor X bar. Therefore, we are at this potential difference parallel and ammeter connected in series. So this is the circuit diagram for Ohm's law. Now, you have seen there is a formula V by R is equal to R. Means R is in denominator and R is in numerator. So from this relation we can say that R is inversely proportional to R, or we can also write this way, R is inversely proportional to R. Means what is the relation between resistance and current? There is an inverse relation between resistance and current. Means whenever the metallic wire having high resistance, then the current flowing through it is less. And if the conductor having low resistance, then current flowing through that wire is more. So there is an inverse relation between resistance and current. Means if resistance is high, then current flowing through is low. And if resistance is low, then current flowing through will be high. So there is an inverse relationship between resistance and current. Now if we draw a graph between potential difference and current. So whenever we draw a graph, between V and R. Now, along x-axis there is current and along y-axis there is potential difference. So whenever we have to draw a graph, along x-axis there should be a current and along y-axis there is a potential difference. Now if we draw a graph between potential difference and current, then we get a linear graph. Linear graph means, why we get a linear graph? Because V and I are directly proportional to each other. Means as potential difference increases, in that constant the current also increases. So this is 2, 4, 6, 8, 10, and suppose this is 1, 2, 3, 4, 5. So current measured in ampere and potential difference measured in volt. So for 2 volt there is an 1 ampere, for 4 volt there is an 2 ampere, for 6 volt 3 ampere, 8 volt 4 ampere, and therefore this is the graph drawn between V and I, and that is called as linear graph. And how we find the slope? So any 2 points, if we just join any 2 points, these are the points. So if we join any 2 points, suppose we have these 2 points, then slope of the graph gives the resistance. Now how we find the slope of the graph? So slope of graph is equal to y2 minus y1 upon x2 minus x1. By this formula we can easily find the slope of the graph, that is we get the resistance. So y2 minus y. So what is y2? This is y2 and this is y, because these are the values on y-axis. So y2 is 8 minus 6. And what is x2 minus x1? x2 minus x1 means these are the value on the x-axis. So this is x1 and this is x2. And therefore x2 is 4 minus 3. And therefore 8 minus 6 2, 4 minus 3 1. And therefore Along y-axis there is an voltage, along x-axis there is an current, and therefore we get the value of resistance, that is 2 ohm. Now if we take any 2 points joining each other, then every time we get a 2 ohm, which gives the value of resistance. So this is the graph drawn between V and I. So what is the nature of the graph? When we draw the graph between potential difference and current, the nature of the graph is linear. So today we have seen what is Ohm's law, then what is its mathematical expression, then what do you mean by the resistance and its SI unit, then how the circuit diagram draw for the Ohm's law, and when we draw a graph between potential difference and current, then what is the nature of the graph.